I'm going to bring on Nicolo again, who's getting very comfortable in this stage, and he is going to help us understand the Vertex AI Builder team.
It's not that I want to always be talking. I'm also replacing some other folks that were supposed to be here today. So, well, it's me again, unfortunately. One of the teams that we're also staffing here is a Vertex AI Builder. The problem we're trying to double skip. There are, as we were discussing before, there are many challenges when developing Gen AI applications. By applications, we mean not just chatbots, everything, like, the websites that we saw, or like you can imagine something that VR applications, anything like that. And the challenges are of several types. There's quality. So what do? Do you do prompt engineering or fine-tuning? How do you do chain inspection? What understand what is going on in your program? Because when you start doing a multi-step process, it's very hard to follow what is going on. It's very hard to evaluate and understand every step of the output that you're producing. In fact, there is a lot of black box problems. Like people, when we deploy our solutions, sometimes today, they don't have the easy explainability. Like they miss, okay, why did this weird answer happen here? How, what should I do here? How do I understand what's going on? Where do I go? What do I change to fix it? And then, of course, there's evaluation difficulties. Like the answer after this is like, okay, go and change that. It's like, okay, if I change that, how do I know that things are still working as expected? How do I know that I'm not regressing in some other areas? And all of these things are like come from, how do I go from prototype, where I see things are kind of working, to production? And also keeping up with the innovations. We discussed an example of models with a lot larger context coming out. This completely changes the way you architect your solution. So sometimes it could. And so basically you need a way to build applications that is able to address partially or completely all of these challenges. And this is what we're trying to do with this high-level builder. For example, I'll just go super quickly through this, but in a RAG system, the one that leveraged the amazing search features that were discussed just a few minutes ago, you have two essential steps. One is preparation of the documents, and the other one is runtime answering these things. And you can see that at every step, the collection, how do you collect? There are web crawlers, there's connectors, there's DBs. How do you process the data? How do you segment the data, preserving the meaning? Which embedding model do you use? Is it multimodal or text only? You transform the images into text and embed that, or what? Which vector database? Well, hopefully ours. How will it perform? And you can imagine that for each of these you have 20 different options, and for each of the options you have a million things you can tune and change and fix. Same for when you run time. For the query, do I need to do the spell check? Do I need to fix things? But there are, specific words that maybe your spell check, might fix, and instead they're supposed to be spelled that way because it's maybe an acronym or something. Do you do rewording? Do you use synonyms? Do you rephrase the queries? The matching engine, is the nearest neighbor search enough, or do you want to use other features? Like what kind of similarity? How do you re-rank? And then, of course, the summarization aspect. Do you use a very big prompt, a small prompt? How much prompt engineering you put versus fine-tuning? And then, serving. There's so many things. And this is just I want to convey how a simple problem like question answering on a bunch of documents can become once you go and tune it, can become very complex. So in Vertex AI Builder, what we're trying to do, and keep in mind, this is super early on. These things can change so fast that maybe it's going to be obsolete a month from now, and we change completely our mind. But what we're trying to do is a development framework that, first of all, is transparent. So it allows you to inspect and understand every step of the process. Then it's frictionless. Well, of course, we're doing Python. It's the Python first, at least. It's the language of choice of every Gen AI practitioner. And it offers a library of pre-built powerful components. Then it offers it's first of all developer oriented. So for engineers that want to build, It offers like a console connected with VS Code, with super strong debugging tools, auto-correcting tools, conformance checks at every point. And then also offers, like, for people that are not coder, for business teams, an ability to, once the system is set up, to go and edit some configuration of the system. I'll show it in a low code mode, where they basically have no code, just configuration, or just very little code. Yeah, and as I said, there's framework and toolings for VS Code. We're also doing beyond VS Code. What's the goal of it is optimize for fast iteration and production readiness. So we want to be able to very easily debug, test, evaluate, monitor. So the way I can frame this for people that have been working on our side is, imagine LangChain. We're trying to build an enterprise-ready version of it, which not only gives you a framework to develop, it also gives you a recipe on how to develop these apps. It gives you you start from this is how you write the test, this is how you run the tests, this is how you debug, run, and basically what we want to also do is this kind of approach where when we go and give solutions to our customers, there are some nodes that are core capabilities. We can call them atoms, our search APIs, our vector search APIs, our chunking APIs. And then we have larger nodes, so things such as, we already built a P&L generator for finance, right? And then we have templates. So a complex app is already built using all of these nodes, and then customers can start from these templates and implement full solutions, customize them. So basically, a lot of the work is already done for them. This is how we aim at achieving scale. How is the developer process work on a day-by-day basis using our framework? Well, first of all, develop and test. In many of the development framework on the open source world, unfortunately, it's only this first step. You develop and test, it's a fantastic experience, you have a ton of tools, etc. But you don't have all of these other things. For all the other things, you need to figure out your other tools, I don't know, Langsmith or Langserve, etc. And there's many options. Here we're offering in one solution a full stop shop to do all of these things in one place. So you can develop and test and iterate. You can run your evals in batches. You can build your own standard evaluation metrics. And then you deploy in production. We will discuss that a fundamental pillar of this is optimized runtime. And then you can monitor. You can see the traffic. And you can basically get the feedback loop of what is going on with your bot so that you can go and start again, fix things, etc. The code that you build looks a little bit like this. Imagine this is how you wire components through each other. I don't want to go through too many details, so possible very much changing as well. But what's important to say is that when you look at this, first of all, you have components that are already pre-built for you, like check safety, check security, rewrite query. These are things that you can use and you can configure. But more importantly, the way you wire these components give the runtime an ability to have an understanding of your code. Very similarly, if you want to make a comparison, a parallel, it's not exactly the same, of course. It's like the way a compiler looks at your code, the way the Java virtual machine looks at your Java code. So basically, it's possible, once you have the structure declared this way, to have a ton of optimization. And these are some of the core areas we want to work on also here. Still, there was a good, okay. The optimizations that you can imagine will happen, for example, here very clearly, this code can look at these two things and say, okay, these two things can run in parallel. There's no dependencies. I can send the query to the check safety and check security in parallel. At the same time, they can start doing this and then decide what to do on a speculative basis. So you're able to introduce parallelism, which is super important, without needing to write parallel code. You can introduce streaming in the same way without needing to write streaming code, because these ops are able to do streaming and are able to do, when an op is not streamable, they're able to act as collectors and then stream. At the same time, you can also imagine that the runtime is able to see the traffic and do things very cool things such as auto distillation. Like, I don't know, a typical, very simple example we do is like we're building, I don't know, called contact center automation tools. And you use these super mega models to say, okay, what's your credit card number? What's your expiration date? What's your CVV number? You don't need a monster of a model to handle these things. You can have very simple, super small, reduced models, auto-distilled from observing 90% of the traffic. And then you have a router that at the top, if someone answers with, oh, I don't have the number because I lost my wallet, I need to find it somewhere, wait a second, then you can give that to a bigger model that knows how to deal with like unforeseen answers. But you can still handle the majority of the traffic with very small, very cheap models. So like this ability, you just write some code, and this ability that the runtime optimizes it for you, it's like super massive, we believe. So yeah, this is all of the things that I was saying. This is how the low-code editor looks like. For example, there is code for you, but we imagine we already have requirements from folks saying, hey, I want my business team. I prepare the structure, IT, like we prepare the structure, the engineer prepare the structure, but I want my business team to go and change things, to edit things, to change the logic. And they need this stuff. They don't want to touch the code. So this is what we offer them to basically scale a usage across business teams as well. And more important, like a super important part of this is like, how do you test it? People are delivering chatbots everywhere, and everyone asks us, how do I know that I'm providing the right answers? It's not easy. And so, well, first of all, you can run test results and you get traces for everything. Tells you the time, you can look at input, output, everything that is going on at every step. And then you can declare, the trace is here, but you can also declare a long list of test cases, and there are already evaluators implemented, but you can implement your own. And you can label tests. You can label tests. See, this is safety in deployment, LLM deployment. So you can run all the safety tests. You can run all the deployment tests. You can run everything. And you can basically, you can run the labels at a given time, and you can run it like custom when you need it. So yeah, this is the thing that you can do in testing. And it's very, I think, important to understand how these tests are very much different from the usual tests that we run in software engineering, because the assertions are not like simple Boolean true or false, right? Is this equals to that? That's not true. Like sometimes what you need to do is saying a good answer for this question is this, and now you need to calculate. Sometimes with an LLM, it's very complex to figure out how to calculate if the answer given by the model is as good as the answer provided as ground truth. And there's a lot of research going on these things. The framework is also supposed to provide at least some defaults on this kind of things. The goal is to, you can, in those labels, you can even have golden sets that are basically, they're supposed to pass 100% of the time. As soon as something is broken, your release is stopped. And you can have eval-based test sets, where it's like, a baseline that you want to keep improving over time, where you don't get 100%. This is it. You can see all of the run details. But generally, before we go to the next one, I wanted to recap. So we are building a framework. And I think every software engineer likes to build this stuff. It's very exciting. It is what we believe is going to allow us to go from simple application to more complex applications, to deliver them to production reliably and to run efficiently. This is something that was asked during the fireside chat. How do you run more efficiently? These are some of the efforts that we're doing. Like, you just build and efficiency is applied for you. We try to put the smartness on our side. And third is like, how do you guarantee? It's like, how do you allow people to constantly evaluate what they're doing so that they have a baseline and they know what is going on with their applications. Looking forward to have many of you working on this together with us. Thank you.